let's talk about SoCs. Now, we all know that they are becoming more advanced by the day, it seems. And with all of that, their core I/O voltages are shrinking, and a lot of times dropping below the 3.3 volt standard required for reliable communication with traditional USB 2.0 cables and peripherals. If you're looking to maintain a robust, high-speed USB 2.0 link while utilizing low-voltage sub 3.3 volt I/O in your next advanced host controller, well then, we should talk about NXP's PTN3222. Because this non-retiming repeater may be the bridge you need. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Nguyen from NXP and I explore the features of NXP's PTN3222 EUSB Redriver. We investigate how it overcomes signal integrity challenges and discuss why it's the ideal solution for ensuring seamless compatibility between your cutting-edge silicon and the world of standard USB 2.0. And before we get started, don't forget to click that link. There you can find even more information about this topic from NXP. Hi, Dong. Thank you so much for joining me.
Hi, Amelia. My name is Nguyen. I am an application engineer at NXP Semiconductors. Today, I'm going to talk about EUSB2. EUSB2 stands for Embedded USB 2. USB 2 supports low speed, full speed, high speed, as in USB 2. eUSB does not support super speed, which falls into USB 3 category.
Okay, so Dong, what were the motivations for developing the EUSB2 specification in the context of shrinking semiconductor process nodes?
At semiconductor process nodes for SoC in smartphones, tablets, and notebooks scale smaller and smaller. Therefore, the SoC supply voltage is getting lower and lower into the 1 volt sub-range. It became impossible for the low voltage SoC to support 3.3 volt I/O cells. Therefore, the main motivation of EUSB2 is to address the need for a low power, low voltage USB 2 for battery operated applications. In addition, there are billions of USB 2 devices in the world. Therefore, it is critical for low voltage SoC to continue to support USB 2 technology in a foreseeable future. And to make seamless transitions from USB to EUSB2, USB2 application software and device drivers remain the same. There are no changes to them. USB2 application software and device drivers continued to work under EUSB2.
Dong, is eUSB2 compatible to USB 2.0?
eUSB2 and USB 2 are not fully compatible. The reason is eUSB 2 signal is 1.2 volts lower, while USB 2 signal is 3.3 volts. The electrical layer between eUSB 2 and USB 2 are completely different. Therefore, an eUSB 2 device cannot directly communicate with a USB 2 device. The application software and the USB 2 device drivers are compatible and remain the same between eUSB 2 and USB 2. USB 2 data rates are compatible. eUSB 2 supports on 3 data rates, as in USB 2, the low speed data rate, full speed data rate, and the high-speed data rate.
Okay, so talk to me about the features of eUSB2.
eUSB2 eliminates 3.3 volts requirements as in USB 2. And to reduce the power consumption, the single-ended eUSB2 signal swing is from 0.9 volt to 1.2 volts. The differential signal swing is also lower from 800 millivolts to 400 millivolts. There are two new modes defined in USB 2, the native modes and the repeater modes. The native modes allows SoC to communicate with each other by eUSB 2 bus, while the repeater modes enables SoC to communicate with a USB 2 device by USB 2 bus. eUSB 2 support up to 14 inches BCB traces between two eUSB 2 devices. USB 2 power consumption is too high for portable applications. eUSB 2 requires much lower power and is targeted for battery-operated devices. Also, eUSB 2 removed USB 2 analog functions and replaced them with digital implementations, since analog circuits can consume quite a bit of power when they are on. No changes in USB 2 application software and device drivers. Two additional features that are not in the USB 2, but they are implemented in eUSB 2, the in-band control message. The in-band control message allows commands from SoC to send via eUSB 2 bus. And the other feature is the in-band register access protocol. In-band register access protocol allowed the SoC to write and read the internal registers of the repeaters. And lastly, eUSB 2 using USB 2 compliant test modes and test software. So that would make the compliant test setup much more convenient. You can reuse the same compliant test setup that you have with USB 2 devices.
Dong, explain the key differences in functionality and use cases between eUSB2's native mode and repeater mode. And what's the purpose of this eUSB2 repeater? And when is it necessary in a system design?
eUSB native mode is intended for on-the-board intercommunication between an eUSB 2 host controller and an eUSB 2 device. They are both placed on the same BCBs as shown in the slides. The eUSB 2 host is on the left and the USB 2 device is on the right. They are connected to each other with BCB traces. Up to 14 inches is allowed under USB 2 specifications. eUSB 2 native mode is not designed to drive a cable such as a USB 2 cable. This means for a device such as a cell phone, both the eUSB 2 host and the eUSB 2 device are located inside the phone. The eUSB 2 repeated modes allowed an eUSB 2 controller to communicate with a USB 2 device. The repeater mode supports both on-the-board intercommunication or off-the-board communication via a USB 2 cable. Repeater modes required an independent eUSB 2 repeater to do signal conversion and voltage level shift from the lower eUSB 2 to the higher voltage USB 2 as shown in these slides. Disassembled, so an eUSB 2 host connected to an eUSB 2 device via a USB 2 cables. USB 2 host is on the left and USB 2 device is on the right. There is an EUSB2 host repeater on the host sides as well as on the device sides. The repeater are needed to drive the USB 2 cable to do voltage level shift and signal translations. This example shows a USB 2 host connected to a USB 2 device. A USB 2 host is on the left and USB 2 is on the right side. The repeater is on the eUSB 2 host side. The USB 2 device can be a mouse or a keyboard, for examples. These examples show a USB 2 host connected to an eUSB 2 device. The eUSB 2 host is on the left and the eUSB 2 device is on the right. The eUSB 2 device can be a cell phone or a printer, for example.
Dong, since eUSB2 is electrically incompatible with standard USB 2.0, how is backward compatibility with traditional USB 2.0 peripherals maintained?
Electrically, eUSB 2 signals and USB-T signals are not compatible, as shown in the slide. The eUSB 2 signal swing is 400 millivolts, while the USB 2 signal swing is 800 millivolts, so they are not compatible with each other. And eUSB 2 redriver is needed for compatibility between eUSB 2 and USB 2. The redriver is used to translate eUSB 2 electrical signals to USB 2 electrical signals and USB 2 electrical signals to eUSB 2 electrical signals. eUSB 2 redriver also performs voltage level shifter functions.
So, Dong, what NXP solution would you suggest in this case?
A few years back, NXP released an eUSB 2 repeater called PTN3222. Since then, it has become a very successful product. We have many customers. It is a 12-pin single-port redriver. It is compliant with eUSB 2 version 1.1 and USB 2 specifications. It supports all three repeater roads as defined in eUSB 2 specification, the host road, the device road, and the dual roads. It is ESD protected. It supports very small CSP and QFP packages. It supports I2C register access interface and RAP. So basically, RAP stands for Register Access Protocol. RAP allows the SoC to write and to read the repeater internal registers. 5.5 volt tolerance on USB 2 pins for 24 hours. These features meet USB 2 specs. Programmable signal integrity support such as long BCB traces, long USB 2 cable, high frequency loads, high capacitive loads, or high DCR. It supports all ambient operating temperature range between -40 and 105 degrees Celsius.
So, Dong, how would the PTN3222 be used in an application?
PTN is a eUSB 2 repeater mode. It is mainly used to drive a USB 2 cable and to communicate with USB 2 devices. I show two examples on this slide. The first use case showed PTN3222 is used in a notebook. PTN3222 is placed between the eUSB 2 host controller and the eUSB2 connectors. The second use case shows the PTN3222 is used in a smartphone applications. PTN3222 is placed between the eUSB2 device and the USB2 connectors. In both cases, the PTN3222 are used to drive the eUSB2 cable and to allow the eUSB2 device or the eUSB2 host to communicate with an USB2 device.
Okay, so can we dig a little deeper into the features of this solution? And what kind of additional resources does NXP offer for the PTN3222?
NXP offer a number of variants for the PTN3222 as shown in this table. The customer can select a particular redriver based on their applications, and NXP allows the customer to choose different functions depending on which repeater the customer chooses. There are a number of options the customer can decide to choose. The factory programmable auto resume timeout, I2C interface as 1.2 volts or 1.8 volts. The reset pin functions, packages, and temperatures. The reset function pin is shown in this column. The reset pin is used to reset the PTN3222, but it can optionally be used to put the PTN3222 in deep standby mode. When in deep standby mode, the PTN3222 consumes only a few microamps. As far as the temperature, the customer can select a normal operating temperature between minus 40 to 85, or they can select automotive temperature from minus 40 to 105 degrees Celsius. And in terms of packages, the PTN3222 comes in a variety of packages. The customer can select QFN packages or LWCSP packages. There are evaluation boards available for the PTN3222. PTN3222 evaluation boards allows the low voltage SoC to communicate with USB2 devices. PTN3222 evaluation board can be easily connected to the lower voltage SoC with a pair of SMP coax cable to the eUSB interface that I show here on the screens. The PTN3222 evaluation board can be powered with a USB2 micro B cable or from a 5-volt AC to DC adapter. A USB2 device can be attached to the onboard Type-C connector, the micro B connector, or a standard A connector. The PTN3222 evaluation board can be configured as host role or eUSB2 device roles. Once the PTN3222 evaluation board is connected to the low voltage SoC, the SoC can communicate with any USB2 device, whether it is a USB2 host or a USB2 device. In addition to the demo board, NXP also offers all the resources the customer can download from the website. There are the user manual available on the website, along with the quick startup guide, the schematic, the I2C GUI, and the layout guideline. There are additional support as well. There are IBIS model and IBIS AMI models. The IBIS model can be downloaded from the website, but the IBIS AMI model, it requires an NDA. Once the NEA is in place, we can send the IBIS model AMI to the customer directly.
Don, talk to me a little bit about the GUI as well.
We have an I2C GUI available to allow the customer to read and to write the PTN3222 internal registers via I2C interface. The GUI only runs on Windows, so the customer needs to have a Windows machine to download the GUI and to run the GUI on the Windows machines. On the screen, this is an example of the GUI interface. On the right-hand side, there are a number of drop-in boxes, and there are many registers corresponding to the internal registers of the PTN3222. You can just select which drop-in box corresponding to which register. Then you select the value that you want to write, and then you click on it. The GUI will automatically write that value that you select to the repeater internal registers. And you can do the same thing with the read. You click on the drop-out box and then select which registers. Then the GUI will read the value from that registers and display it on the screen. So it's very simple operation to use the GUI.
Excellent. Now, Dong, there's an updated version of the PTN3222, correct?
Yes, we are planning to release the next version of the PTN3222. The part number has not been defined yet. It is still a one-port, 12-pin Redriver. It is updated to support EUSB2 version 1.1 and it compliant with all the ECN. ECN stands for Engineering Changes Notification. It supports BC 1.2, CDP, and DCB charge emulations as defined in the BC 1.2 specifications. I2C interface is available for the SoC to read and to write the internal registers of the PTN3222, but it also had a non-I2C mode that uses pins to allow the SoC to set the internal register instead of the I2Cs. It supports 3 I2C voltages, 1.2 volts, 1.8 volts, and 3.3 volts. The previous versions only support 2 voltages, which is 1.2 volts and 1.8 volts. We have feedback from the customer that they want the 3.3 volt I2C interface as well. So the next revisions of the PTN3222 will have the support for 3.3 volts I2C. The revision parts will support the same small packages as the PTN3222. It supports CSP package as well as 2 FN packages. EUSB2 was designed for embedded applications, but it is being used in other applications as well. We have customers use them in automotive applications, home and automation, IoT, industrial applications. EUSB2 is gaining a lot of traction in the market the last year or so. EUSB2 is not a replacement for USB2. It was designed to work as a low voltage embedded USB2. I hope today's talk will give Chalk Talk audience a clear understanding of what EUSB2 is and how it is used as a low power, low voltage USB2.
All right. Well, Dong, I think that's all I have time for today. Thank you so much for joining me. And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from NXP. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EEJournal.